Hi, I'm Mr. Waite here at Westfield. We're looking at the topic thermal decomposition, and today we're going to investigate 3 metal carbonates and their rate of reaction. We're going to use lime water, which turns from clear to cloudy in the presence of carbon dioxide, as an indication of that rate, because in this reaction carbon dioxide is a product made. Before we get started, let's look at the equipment, let's look at the apparatus setup, and we'll begin. We've got 3 metal carbonates. We've got lead carbonate in this boiling tube at the moment, and in 2 other boiling tubes I've got iron carbonate, which is brown in colour, and copper carbonate. And I used a spatula in order to transfer the metal carbonates from their containers into each boiling tube. Lime water, stop clock, clamp, and I've got a stand, Bunsen burner, and that's got a heat-proof mat underneath it for safety. This orange thing here, which is a bung, and out of the bung centre is a delivery tube, and it does what it says on the tin. It delivers the gas into this test tube, which contains the lime water. And the final bit of equipment, it's not necessary, but it just helps. I've got a box here, and I'm going to position it just behind my test tube, and that can give us a better indication of the cloudiness level of the lime water when compared to a different background. So that just helps make it clear to us when it's turning from clear to cloudy. In terms of the method for this reaction, I'm going to light the Bunsen burner. I'm actually going to allow this reaction to occur, leaving about 10 seconds before I insert the delivery tube into the lime water, because what tends to happen is that as it heats up, the air inside of this boiling tube will expand, and it can be released as bubbles through the water, but they aren't bubbles of carbon dioxide. So just going to, for each of these, leave about 10 seconds, just so that we know that the bubbles that are probably being produced are carbon dioxide. Let's talk about the variables in this practical. So the variable that I'm changing is the independent variable, and that is the metal carbonate. So I've got 3 metal carbonates as my independent variable. Dependent variable, which is the thing that we observe or we measure, that is going to be the rate or the speed that the lime water turns from clear to cloudy, and I can use my stop clock to time that reaction. Control variables, these are things that we do in order to make this experiment as accurate as possible. One thing to control is the mass of the substance. Now you can use weighing scales to do that. I haven't chosen to do that today. I've just used 2 heaped spatulafuls of each metal carbonate into each boiling tube. I have measured out the volume of lime water, because different volumes of lime water might take different amounts of time to go from clear to cloudy. So I've put in 4 centimeters cubed of lime water, and I will do that after each round of the experiment. I'm also going to try and keep the heat in the same location on the boiling tube, just so that the coverage of that heat is equally distributed across that metal carbonate. Okay, so I've got my goggles on. Before I start the practical, I'm just going to give you an indication of the colour change for this lime water, so that you know when the lime water has fully reacted. In order for me to do that, I'm just going to blow into the test tube, because I produce carbon dioxide through respiration. So that is the colour that you're looking for when the reaction has completed. We're ready to go with our first metal carbonate. This is lead carbonate. So I'm going to light the Bunsen burner. I will put the Bunsen burner on a blue flame, place it under the metal carbonate. You can see that I've not allowed the delivery tube to be under the lime water. I'm going to leave it for 10 seconds, then I'm going to put it in. You will start the timer the moment that 10 seconds has elapsed. 3, 2, 1, go. So carbon dioxide gas is being released. I want you to make the judgment when you think it is turned fully cloudy. Okay, I'm going to take the heat down and move the Bunsen burner out of the way. You should have timed that, and now you can record your results down. Three, two, one, go. You can see that some gas is coming out of that test tube. Okay, I'm just going to stop it there. Three, two, one, time. Okay, I'm going to move that out of the way. Hopefully you now have got 3 sets, well, not 3 sets, but 3 values, 3 numbers you can see and compare to your prediction which one was the fastest reaction, which was the slowest reaction.